Check. So very good afternoon everybody and welcome back post the break, and we begin the last session of India Steel Conference. This is a panel discussion on digital technology and steel industry with respect to steel making and digitalization. I invite on stage Shri Amarendu Prakash, Chair, FICCI Steel Committee and Chairman, Steel Authority of India Limited. Welcome, sir. Shri Vinod Kumar Tripathi, Joint Secretary, Ministry of Steel, Government of India. A very warm welcome to you, sir. Shri Pinak Dattare, Founder and Chief Executive Officer, Robotics AI. Welcome to you. Shri Stefano Pari, COO, Region APAC and MEA, SMS Group. Welcome. Shri John And, Founder and Chief Executive Officer, Ronmas GMHB. Welcome. And the session moderator, Shri Abhijit Ray, Partner, Deloitte. Welcome to you as well. So let us put our hands together for all these expert gentlemen on the stage. Before we get into the deliberations, at the outset, let me call upon Shri Vinod Kumar Tripathi, Joint Secretary, Ministry of Steel, Government of India, for the welcome address and context setting. Sir.
Good morning, ladies and gentlemen. It's a good afternoon. Esteemed speaker on the dais, esteemed guests and delegates, it is my pleasure to welcome you all to today's session on steel making and digitalization, a topic that stands at the intersection of tradition and transformation, where one of the world's oldest industry is embracing the future. The steel industry, long recognized as the backbone of modern infrastructure of the country. It is undergoing a pivotal shift as we navigate the challenges of 21st century. From sustainability pressures to global competition, digitalization is emerging as not just an option, but a necessity. At the heart of this transformation lies data, the digitization before digitalization. But before we can leverage data effectively, we face one of the most critical challenges, the creation of sanitized, high-quality data. In a typical steel plant, data streams from thousands of sensors, control systems and legacy platforms, often fragmented, inconsistent or unstructured. Turning this raw information into clean, meaningful data sets is a foundation step. Without this, the promise of digital technologies like AI, machine learning, and advanced analytic learning cannot be fully realized. Once the hurdle is addressed, the use of data for process efficiency and energy optimization opens up immense possibilities. Real-time monitoring and predictive analytics can fine-tune furnace operations and reduce material waste. It can also lower energy consumptions, outcomes that are not only economically desirable, but crucially for meeting global climate commitments. Data-driven decision-making allows for smarter production planning, better quality control, and more agile responses to market fluctuations. Another strategic benefit of digitalization lies in inventory minimization. By integrating data from across the supply chain, from raw material sourcing to finished product delivery, Companies can align production more closely with demand, reduce buffer stock, and improve cash flow. Digital tools enable dynamic inventory tracking, forecasting, and replenishment strategies that lead to leaner operation and reduce overheads. As we explore these themes today, let us remember that digital transformation is not about replacing people with machine. It is about empowering people. Empowering operators, engineers, and managers with better tools, better data, and better insight to make more informed decisions. I look forward to the discussion ahead and to hearing your insight on how we can continue to drive innovation in this vital industry.
Thank you, sir, for the initial remarks, setting the tone of this session. I will now request the panel moderator, Shri Abhijit Ray, partner Deloitte, to please take charge. Over to you, sir.
Thank you, ma'am. Good afternoon, everyone. I can see a lot of people are deep into their phones. You are using digital technology. Today we have a very, very interesting panel. We have policymakers, we have one of the biggest producers, and we have got absolutely cutting-edge providers to this industry. I'm not a steel industry expert, but I've been working with digital for the last 27, 28 years across various industries. So I'm a student of this subject, and Mr. Tripathi mentioned that it's one of the oldest industries. The way I look at it, that gives us the maximum chance to innovate. So that's where some of my questions will come. And I will try to leave some time for your questions to our esteemed panelists. So think about, listen to them, their perspectives, and then I think your questions will kind of enrich all of us in terms of our understanding of the subject. So firstly, I will start with Mr. Prakash. As we all know that SAIL has embarked on a very, very large and pervasive digital transformation. Just wanted to kind of pick your brains. Why and what outcomes are you looking for at a very broad level?
Thank you, Abhijit. Digital, when we talk about digital today, I find boundaries merging. You see, we had automation first, computerization, automation, late 90s and late 90s. The whole industry was on the spree to automate and computerize the processes and things. From there, we graduated to being digital, and today we are practically on the cusp of AI. We are talking about AI built over the data in order to analyze the data. Machine learning and AI is coming in. So the thought that we are traversing, hoping to traverse over the next 3 years through our digital initiative is kind of a mix of all of this. So we'll be building on that. Interestingly, as we expand capacities, as we struggle with the challenges of choosing the right technology and trying to decarbonize our industry, efficiency has emerged as a buzzword in our industry. Efficiencies are very good. Some of the decarbonization initiatives are out of money. That means that you change the process, you invest money, which may not necessarily be returned in the price of steel, in order to adopt those technologies. However, the good thing about digital is, this is in the money question. To just give you an example, with the current initiative that we have undertaken, we will be spending something like almost $30 to $40 million with an ambition to, at the end of the program, we are trying to add $120 million to the bottom line per annum. $120 million to the bottom line of the company per annum. And mind you, this is half the target. I believe this is just half the target. The potential to transform your industry, transform your business through digital is going to be double of this. So we have started off on trying to add 120 million. Just by investing 30 to 40 million one time, you can do 120 million. So that's the scale and that's the kind of potential that digital holds for our company. And I'm sure this is true across the industry. The whole digital exercise is not just about getting efficiency in the steel plant or steel process. It is not just about the metallurgical process that we are trying to control and trying to improve. You know, whenever the steel industry, one of the features of the steel industry is whenever you set up an integrated steel plant, you practically set up a whole city, you have got so many operations. I personally believe that digital has a lot of scope to automate many things there. So my procurement process, for example, my financing activities, the accounting activities, all of this can be digitalized. If I've got a township, and I invite the audience to think about this, it is not just about whether you understand the steel making or iron making process and what digital you can put in. If you can put in digital smart meters into the housing, I have got 33,000 dwellings in my city. One city, 33,000 dwellings. Imagine at the scale of sale, with we have got about 13 cities, more than 100,000 residential dwellings are there. If you can put smart meters there, it will help me. So that's digital to me. That's the kind of potential that digital has. If you can go into my cities and streamline my waste management process, the municipal solid waste, how it will be tracked, whether it can be segregated. If you can put digital into that, imagine the kind of savings that you can accrue to me. So it's not just a drive to improve a very technical metallurgical process, but it's a question of making digital a way of life in everything that you do. And it has huge potential as we see in our business. I'm sure others in the business will also appreciate that. Thank you.
Thank you so much. It's absolutely fascinating and inspiring, right from automation to AI to actually thinking about people who live in that ecosystem and everything, because if we can expand our horizon, digital can change lives. Digital can change our competitiveness, our capacity, focus on green steel making. And also, it is not nice to have, as we heard from Mr. Prakash, it is adding real impact to the bottom line. I think to me that's the key kind of takeaway. And I will come back to you with certain questions because it is, I don't know what's the right term to use, whether it's a traditional industry and all that, and I only see opportunities. There are other things that needs to be in place to make digital happen. So before going into that, I've got a question for you, Mr. Tripathi. We live in a global economy, and there are, even in this panel, we have got global experts. So one thing I would like to understand is how tech partnerships in the steel industry, and what's the role you see about global players contributing to India and India contributing back to global, given that we are world's second largest steel maker. It's not about just global company helping us. We have got a lot to kind of export in terms of knowledge. So the question is around technical partnership globally. Would you love to know your perspective?
See, partnership is always good because see, working individually or in a team, it makes a difference. And as far as digitalization and AI is confirmed, India is one of the leading country which is doing a lot of work in this. So India can contribute to the world and take the best of the world also. So working together will always lead to a better result and better outcome. That's what I think.
Yeah. No, I fully believe because we have to be globally competitive, and there are stringent regulations across the world, and those regulations are not far that India we have to all follow, if not already there. So thanks for that. I've got a question for Mr. Parry. We had a interesting little discussion before this talk. So there is, so SMS Group, you have been a leader in the steel industry across different processes. My question is, and we were discussing, digital is not a software. How digital adds additional value to an existing producer? Would love to know your perspective.
Thank you for the question. Makes my life really easy because as a company, SMS, when we started more than 10 years ago, the first, we call it the first learning plant. It was a plant that we established in the US. We understood the potential of the digital revolution and its application in the steel industry. And we have elaborated a concept that goes beyond the traditional way of doing business. The difference between digital steelmakers and non-digital steelmakers is really visible. Digital steelmakers are using to the utmost of their potentiality the data, the information, everything that is coming from their IT system, automation, sensors, whatever, and they can take out of this the potential that non-digital steelmakers are not using. So we see this as a deep transformation of the way we do business in the sense that we are now elaborating cooperations. We were talking about partnership just a few moments ago because our value proposition is now a combination of a digital package that goes together with the automation package of the plants and that goes also together with the ability to provide servicing to our customers. So these three elements that are combined in a solution becomes not the traditional way of doing business, so we sell a plant and then we leave, but becomes a journey that we take together with our customers in a continuous improvement and development trip that takes out the best from the value that can be expressed from the plants.
That's fascinating. And as I was talking to you before this session, I think what struck me is from providing equipments or part of the solution to having a continuous stake in the outcome. It's not about selling equipments and solutions and then going away. Now digital through sensors, right from maybe from where, I don't know, your organization monitors and tracks, but essentially it is about suppliers having a stake in the outcome with constant monitoring, and that means that your business models can also kind of change. It's not about you pay and go away. You can actually innovate on the business model, and I'll come back to you on that. I've got a question for Pinak, and you work in a very, very exciting area of AI, especially around vision AI and all that. Can you kind of share with us what are the top use cases that maybe our audience would like to prioritize, given what you're seeing from your experience working in the industry? Yes, over to you.
Sure. So in today's steel manufacturing context, right, the bar on cost competitiveness, the bar on sustainability, it is only increasing year on year, day on day, month on month. And the fellow panelist, sales chairman sir, I have heard him speak that steel making is an art, and he likes to call himself as a bachelor of art of steel making and not bachelor of science. And unfortunately, in today's world, the crop of the artist, it is reducing. So all steel makers today have this double whammy, where on one hand, the pressure on cost competitiveness, the pressure on sustainability is only increasing year on year, month on month, day on day. but the crop of artists, it is reducing. Which is where I think the power of AI can really be a solution. It cannot be a magic wand. It cannot be one thing that solves all the problems, but maybe partly alleviate the problem, reduce the pain. The way it can reduce the pain is automation of decision making. So while in the last 5 decades, the steel industry has gone through first the electrical and instrumentation level of transformation, the L1 as it's commonly called, and then L2 level of automation, which is the automation layer, and then the L3 of MES in the early 2000s and the late 1990s. And over the last 2 decades, we have the IT layer and the Power BIs of the world, and now AI. What AI is literally doing is it's taking each of the decisions that people are taking on respect to material dosage, material sizing, material quality, temperature, fuel flow rate, residence time in different equipment, and automating those decisions so that even if you don't have the perfect artist in every shift, in every unit, the AI can get to a decent level of performance. Use cases, as you asked, some of the most interesting use cases I feel are in material monitoring and equipment monitoring. In material monitoring, in a steel plant, 45 to 50% of the cost base is the carbon cost base, which is largely consumed in the blast furnace. Now, within the blast furnace, if you control and have a real-time visibility into the sizing of the coke, sizing of the sinter, the quality of the sinter, the moisture in the coke, then the fuel rate can be far more controlled, leading to a throughput and energy efficiency. And that is where the power of Vision AI comes into play. So it's easy to put cameras, but what it's very difficult to do is have an automated pair of expert eyes that monitors the process. Vision AI is like that automated pair of expert eyes, constantly analyzing the video feed, raising alerts when there is an anomaly, nudging you to take actions. And in some of the cases, we work with the steel plants to also automate those actions. So we do automation of the fuel rate, we do automation of the conveyor belts, we do automation of the residence time, and those are some of the use cases that we have been working with.
Yeah, this is fascinating. I myself work with Vision AI in other sectors like transport, metro rails and all that. And what struck me is that not necessarily we have to put fancy sensors and everything else. It's way easier to put on camera. I think the magic lies in what do we do with the image feed. And as Pinak, as you have mentioned, is with the vision, then with AI, and if we can loop back to the action and the automation, then that's when magic can happen. Often we think that, okay, AI is a fancy story. Can it work in my aging steel plant? And suddenly when you use camera can bring that magic with the power of data and AI. So thanks a lot. I'll come to you, Dr. John. As a global innovator in robotics for industrial environment, can you share how robotics is reshaping steel industry, especially in the areas of safety, precision? So what are the kind of top use cases you are seeing?
Yes, thank you very much for this question. Before I come to that, before I come to the robot, I would like to make it more a discussion here and come back to what Mr. Prakash said and also Mr. Pari about intelligent sensors and measuring process data in our lines. This makes absolutely sense. So I'm a strong supporter of measuring everything you have. We have all process parameters and simply store them. So I had a nice story. Nobody would believe. I'm a metallurgical engineer and I didn't believe it when I heard it first time. A big German steel producer 5 years ago had a problem with the toughness of the steel. They had a big lot, and from time to time the toughness was really too bad. And the metallurgists in the lab could not find the fault. They could not find the reason for that. And their last hope was a little bit AI, more big data. And after a week, the researcher came to the metallurgist and he said, I know it sounds stupid, I know a little bit of metallurgy, but the data look like your sulfur content is too low. So, everybody says cannot be, but after doing some research, they really found out. So this is the reason why I'm really a strong supporter of measuring everything. And when we get for our machines inquiries mainly from Europe, from Germany, the standard is now to integrate into our package units like robots and machines which help here and there to integrate sensors for measuring, for example, the power consumption, the air consumption, hydraulic history, and. When I say to people, tell the people, this makes your equipment a little bit more expensive, they say, I ask, what are you using the data for? And they say, we don't know yet. Maybe we're going to use it in 5 years from now. We simply store it. So they are expecting the future. They are preparing the future. They don't know what to do with the data right now, but they simply keep them. And this is the way of thinking we need today. So today we do the preparation for the future. But coming back to the robotic question, sorry for the short story in the beginning. Yes, you mentioned 2 drivers for integration of robotics into our plants. One is safety, of course. So safety was and still is the main motivator of using industrial robots in the steel industry. With idea behind it is simply to keep the operator separated from movements. So this will reshape our layout. This will reshape our way of working with the machines. We had a customer in the United States who every time that he wanted to access the robot to do something here or that, a little bit maintenance, he used 3 hours of shutting the machine down to have access to the safety area, and then 3 more hours to activate the safety area again. This is something that has to change. We have to think our layout, our concepts in a way that we think with the robots. Second, you mentioned was precision. So precision I see as a part of quality. So precision on a tenth of a millimeter, we don't need so much in a steel mill, in a blast furnace, but the more we come to an end there, we need it. So the robotics that we use, industrial robots in the hot area, are more for the heavy work, for safety. When we come to the end of the lines, more for the precision. But one more thing also related to quality is usually, I say usually, robots don't do mistakes. So one really important aspect is marking. We did once a trial on a night shift in an arbitrary plant, and we noticed that we have an error of 3% of wrong markings. 3%. When you use a robot, you have 0% of wrong markings. Everything the robot does, it does like instructed from the level 2 system. So, and you know, when you count your inventory and you find a slab that is not in your system anymore, you know you have 2 problems with 2 customers, and the only thing you can do is wait until the problem comes to you in case of a claim. There are 2 more aspects besides safety and quality. One is, of course, reliability and output. So there are cases where a simple integration of the robot increases the output. For example, we had recently the case where the operator has to go into the machine to cut the strip and then leave the safety area again. This took 5 minutes. You have the robot and do this by a robotic operation, increase the output by 10%. Only addition of 1 robot. If you do this analysis, you find easy ways to increase production. And I'm not a friend of saying as you said, replacing operators just by robots. No, we try to educate, to train the operator who has done this before in maintaining this robot, not only this robot, but all robots, to refill something, to do maintenance level 1 on these robots. And last but not least, it's of course reducing the costs. So as I said just now, one operator can care for a couple of robots, and you need one robot for 3 shifts, replacing 4 men that can be used in a different place. So these are the 4 drivers, the 4 motivators for industrial robots in steel plants.
Brilliant. So thanks a lot. And thanks for the initial but very useful digression. And I firmly believe that capture data from wherever you can. And I used to work in Microsoft before, and we used to use a term called data exhaust. Capture anything and everything you can. We can figure out that use later on. Because if you don't have the data, all the fancy things that we are talking about, that doesn't work. So we all have heard from our esteemed speakers that why digital is important and what are the areas it can make an impact. So my next set of question is that if we know the why, how do we get there? And the most important thing maybe is nothing to do with technology. It is about us. It is about us humans. So Mr. Prakash, I have got a question for you. Digital transformation, given the pervasive journey you have taken, how are you approaching the internal transformation of your direct leaderships and levels below so that they can actually, they make the organization ready for this change? Because us as human, we don't like to change. And you are changing everything, so would love to know your perspective.
Great question, Abhijit. Yes, more than the data, more than the automation, more than the robots, we need to change minds. So, truthfully, we named it not just digital implementation, but digital transformation intentionally, because we realize it's a big change management exercise. What changes? The mind changes. Two issues I'd like to just mention here, which will bring out the context of how the mind changes, and it is interesting to talk about what John is doing. One thing is safety. How many times have you seen when we sit down we are manufacturing safe practices, unsafe incidents that happen, and every month when I sit down with the whole team to look at, we analyze what are the unsafe incidents that happened, any accidents that we happen. You know, traditionally we used to start with what was the standard operating procedure? Was the standard operating procedure followed or not? Who violated the standard operating procedure? What was wrong? Can we improve the standard? It was all about standards and procedures and laid down guidelines. You know how we start now, how we have changed, and today how we start our safety discussion. We say, okay, fine, this incident happened. Where did this happen and what was being done? And we say, can we stop this activity? Can we eliminate this activity itself from the process? We will not do it. An accident happened was because somebody, and I have colleagues with whom I have had these discussions, somebody was unhooking a wire from a live electricity line and got a shock or something happened. And we said, why did he need to do this? Can I stop this? I will never hook or unhook a line from the electricity line. Can I do that? Can I manage that? So that's the first question. But interestingly, as soon as we say we are a steel maker, we need to do this. I cannot stop producing steel. The second question is, can I eliminate the man from the process? And that is where it is so important. And we really are eager to look at robotics, mechanization in some cases, to just eliminate the man out of the process. Why do we endanger men? Man's life is much more important to us than the process. So this is the way we have started thinking about safety, because today we have robotics available. Today we have digital available, which can actually help us in replacing a person from the process and getting something else there. So that changes the mindset. The second mindset change, and this was interesting to me also in our company, what we did as we were embarking on this exercise of this. We simply launched a drive last month, I think more than a month ago. We simply put out a competition. We said, are you using digital? And we reminded them, whenever you are using your phone, whenever you are booking your air tickets on the mobile or maybe you are doing internet banking. This is all digital. And so we asked our people that we are launching a competition. Please tell us how you are using AI, already using digital in your workplace. Very interesting insights. I'll just quote one. Somebody wrote back more than 500 entries, by the way, from the organization in 1 month. And we have not started our digital journey and people are already using it. How they are using it, somebody wrote back, and the example was, they said there was a project proposal that the officer was to analyze because he has to go and convince his boss that this project proposal is all right and requires to be approved. So what he did was he picked up one of the AI engines and he did not go through the project proposal. He simply took the project proposal, put it into the AI engine and asked the AI engine, is the project proposal all right? And the AI engine, trust me, responds, look at the eligibility criteria. It seems to be too restrictive and so you don't land in trouble with your boss. He says, fine, okay, I'll take a look there and I'll improve this. Then we are a government company, you know. The project proposal is probably 50 pages. My manual to make sure that that project proposal is in compliance is 200 pages. So the next thing that the person does, very smartly, he puts in the whole guideline, 200 pages of guideline into the AI engine and says, okay, now tell me, is the project proposal meeting all the guidelines or not? Very interestingly, the AI engine actually came up with 3 clauses where he said, please check your proposal. It is not meeting different guidelines on 3 clauses. I had never thought about it. Frankly speaking, when it came as an entry, I was really impressed that how useful lazy people can be. They can make the world really efficient by being lazy and actually using the tools which are becoming available there. That's the innovative spirit which we will want our people to have. So our journey to the 120 million, or as I say, the target should be double of that, the 240 million, will involve this kind of spirit in our people, and this is what we are trying to get them. We are opening the doors for them to experiment with it, work with this, and adopt this not as an order from me, but because they like it and they play with it. So that's the approach.
Brilliant and absolutely inspiring. And in our journey for digital transformation, I think we often fall into the trap of automating what humans are doing. And the key message I took is that rather than having that automation mindset of doing faster, do we actually need to do it? Can we do, in banking term, they call it straight-through processing? Can we kind of eliminate that thing? And the second part is, the best ideas may not be at the top. The best ideas are across the organization and maybe beyond the organization. So the way you harness the innovation spirit, I think that's absolutely fascinating. Dr. John, you wanted to add something?
You noticed that? Thank you very much. Yeah, I love discussions more than presentations. And I have so many ideas, maybe like you also have. So seeing the statistics for accidents in Germany, I don't know if it's in India the same, but it should be. So the real hard accidents, the number goes down, the fraction goes down. What is left in Germany is, because Germans love to go on sick leave, is standing, walking, climbing. What can we do? We cannot put them in cotton and that they don't fall anymore. So there are actions that cannot be avoided, we think. But now seeing videos from Chinese humanoid robots, we think, okay, there are simple actions like going to the magazine, bring a pot of paint and refill the paint marking robot. This is done by an operator. Why can't that be autonomous by a robot? Send the robot to the magazine and let the robot fill the paint tank. Why not? So we can, when we think one step further, we can eliminate also these actions.
Yeah, and as Dr. John, you were telling this example, I think we all think, and with the advent of AI, Gen AI, Agentic AI and robot, we often think that humans will have jobs. I think the way I see it is that from automate to elevate the humans. We can, the same person who has been very experienced in the shop floor, can we ask that person how we can make the process better rather than working harder? So I think as humans, we have got a unique opportunity to elevate ourselves. So my next question, Penak, to you is, you were talking about a very interesting use case about Agentic AI. This is Agentic AI is the new buzzword, and I'm part of the technology industry. We are kind of guilty of coming with really fancy stuff. Half of them doesn't work in real world, but Agentic might actually work. So Pinak, what's your take on it and what are the use cases?
Sure. So I think, let me first demystify, I think for the larger audience, what is Agentic AI, right? There are three words, Agentic, Artificial, Intelligence. Now, let me start with the third word first, which is intelligence, right? So you have data, structured data is information, intelligence on top of it leads to an insight, and collection of insights is intelligence, right? So that is intelligence, and all of us are well endowed with it. When a computer starts to replicate that, it is artificial intelligence, right? And what is then agentic on top of it? So typically so far, till like last year or so, artificial intelligence was used to only automate part of workflows. So if there is a long workflow where person A does something and then something and something, it's a full workflow and only a part of it was facilitated or replaced by using the power of AI. But now I think the Gen AI particularly has got us to a world where the full workflow has been replaced. And just like Chairman sir gave an example that someone doesn't need to tally his proposal with the guidelines and then AI is doing it. Language model, Agentic AI is doing it. So that is like Agentic AI. Now Vision Agentic AI is where we work. So basically we deploy computer vision agents on top of video feed to do 24/7 visual anomaly detection, give real-time alerts with 95% accuracy, and also automate decisions based on that. Some of the use cases are flare stack, for example. There is a lot of flaring happens. Today there are flow meters. Flaring happens only because the gas balance is not 100% balanced, and the excess flare is flared off. The problem is that while people try to automate and optimize that, but lot of times flow meter go bad, and people only realize later on that excess flaring is happening. So what we are doing is by computer vision, 24/7 monitoring of the flare stack, we are continuously iterating and optimizing on the gas balance so that flaring is reduced. There are multiple steel plants that we are working with, and we have reduced that by 2 to 3%, the overall flaring, which is millions of dollars of bottom line improvement as well as greenhouse gas emissions. To give you another example, downtime is one of the pain points of every steel person out here, right? No one wants failures in life, and no steel professional wants a downtime in the plant. And there are typically lots of equipments, right? 25,000 equipments typically in a steel plant. About half of them are rotary, other half is non-rotary. And while predictive maintenance has really evolved in the last 3-4 decades for the rotary equipment, but for the non-rotary equipment, it continues to be a problem. Which is where, again, we deploy Vision AI agents. So while it is very easy to put cameras out there, but it's very difficult to put human eyes tracking the cameras. And which is where the Vision AI and Agentic AI comes into play. So the Agentic AI replaces the people, the need of people to continuously track the video feed, and it does the workflow for you. So it will, for example, in a steel plant, there are 1,500 conveyors, and first there is a scratch, then there is a tear, and then there is a belt failure. And it's very hard to continuously track it, which is where Vision AI agents deployed on 1,500 cameras on top of 1,500 conveyor belts can always continuously monitor the health of the conveyor belt, identify early signs of wear and tear, and completely eliminate belt failure. Typically 1 to 2% downtime in any steel plant is because of belt failures, and entirely that can be eliminated using the power of Agentic AI, using the power of Vision AI agents.
So thanks a lot, Pinak. I read a very, very interesting comment couple of days back, and we have all heard it, that in computer system and AI, garbage in and is garbage out, right? So the data quality is very important. In the age of AI, it's actually garbage in, garbage squared. It is scary. Now we have got the power of NVIDIA chips and anything else, all the stuff that we are talking about. If the data quality is incorrect, and we will be depending on, let's say, evaluating large proposals using my manuals or other safety equipments. So, question to Mr. Pari is that we're all excited about digital, but what are the foundational things we need to get digital ready?
Good question. When we talk about digital packages, we normally refer to what you just said exactly, to the digital readiness. Digital readiness means that the equipment, the plants, the sensors are available, are fully utilized, and that we understand their value. Traditional steel manufacturing is very frequently conceived as a heavy, sturdy, strong, not sophisticated, not like a pharmacy. But when we talk about digital models, and we talk basically about computers and data, we need to understand that even the last of the sensor that is installed on a rolling mill can make a difference. So it is important for our customers to understand that they have to put a different level of attention, not only taking care of the big motors or of the big parts or whatever makes the real steel, but also they take care about keeping in a sufficiently fit state the digital assets that are contributing to this.
Yeah, thank you. Because this is the unglamorous part of digital transformation. And two most areas which adds the most impact is our people readiness and their participation. Second is, are we creating the foundational infrastructure? Do we have the right sensors and the way to capture the right data? If we have data, then we can do agentic as it's fashionable today and many more models that will come. And often there isn't an immediate payback. And I keep advising my customers, see digital in totality. Don't think that this is a point solution, I will get a quick return. There might be some use cases, but I think as we are deeper into the discussion, it is not about a digital point solution. If you're hearing the word digital transformation, this is a once in a lifetime opportunity for all of us to really transform our organization and the industry. So how we see the connectedness of different things, and increasingly we are seeing that connectedness in the examples. I've got a question for you, Dr. John. From whatever you have seen in India and abroad, if there is one or two top use cases around robotics, what are the ones that India should be focusing on to kind of, whether it's safety, operational efficiency? It's almost like if I remember only one thing or two things, where should I focus on?
In general, yes. I've seen many steel and aluminium plants worldwide and also in India. And what I have to say, a modern steel plant in India looks the same like anywhere else in the world. So I wouldn't make any difference between a typical Indian and a foreign steel plant, not at all. So the structure is the same, the way of working is the same. But of course, we know in all countries we have these 50-year-old mills where automation is different, all close to zero, but they will be closed in a couple of years or modernized. So, as I said, no major difference. So actually, I would say there are 3 different levels of integration of robots into steel industry. One, the lowest level is we check the internet for suppliers and check which robots are available. We have some in the steel plant for the dangerous work like changing hot equipment, measuring temperature. There are robots in the rolling mills like cold rolling mill, de-strapping robot, labeling, marking robot, welding robots for securing the safety or the shape of the coil inside and outside. We have sample moving robots. We have the first AGVs. We call them also robots. This is the level number 1. Check in the internet what's available. There's a huge variety of industrial robots specifically made for metals industry that are available today. Second is invent your own robot. Go and check what's needed. Actually, this is the favorite part of my own job, going to an existing factory and seeing with digital eyes which action with which process can be automated and which workplace can be replaced by a robot. And number 3 is let's do a total different thinking. An example for an old thinking I have from Germany, working on a project and recommending one specific customer marking robot for the end of his line, and everything is ready. We are about to get the order, and then the question from the customer comes, German customer, high quality aluminium mill. This proposal is rather nice, but instead of the robot, can we have a linear system? So, crap. So, for the linear system, we need an engineer to design, we need the purchaser to order, we need all the paperwork in the background, we need our workshop, and we need an instruction for the people. So, and for the robot, we need just the purchaser to purchase one piece of robot. That's it. So that's the difference. The opposite, and that's why I'm telling this story, the opposite I've seen in China. Steelmaker in Chongqing has a 5 program. 5,000 robots in 5 years. Go. At the end of these 5 years, they will see 4,000 robots was a waste. But they will, I'm sure, they will have invented 1,000 nice robots. So force your people to think different, force your people to think the future now.
Stunning, absolutely stunning. Make your own robots. I think that's the key takeaway. And so I'm part of the software industry. And around 15 years back, Mark Andreessen, he was the founder of Netscape, he made a comment that software is eating the world. Hardware is commoditized. Now is the time where hardware is again becoming strategic. In the computer world, there is a mad rush to buy GPUs. You can see the stocks of NVIDIA and other stuff, especially for really unique and competitive advantage use cases. Can you develop the skills to build your own robots? Because that will give you a competitive advantage. I think that, and think of it like software. Now there are composable materials in the hardware, computer hardware technology, where even I was seeing a video where warehouse stacking, there are composable elements. You can almost give the instruction to that robot. It rearranges itself to have the right kind of warehouse stacking. So even hardwares are getting flexible so that you can recompose for your use cases. So that's fascinating. My last question is, Mr. Tripathi, is that you are kind of re-energizing the organization SRTMI, and this is around R&D. So if you, just because making our own AI, making our own robots, so can you kind of share your thought process and vision of how SRTMI can really help all of us in this industry?
SRTMI is for research in steel sector, and Government of India acts as a facilitator in this. SAIL chairman is the head of that organization. So it will facilitate the whole industry come together and share, participate in this, and in projects which may concern the whole industry, the major players can come together and do the research, share the patent, and then implement these things in their process making and steel making and cost cutting, all those things. As far as digital part is concerned, the digitization, which I said in my opening remark also, that is most important, as it has been discussed here also, that we have to first capture all the data by right sensors, right cameras, and create a data bank, and then sanitize that data and make it structured. Only then the AI and machine learning part can utilize that for the optimization part. The Government of India, in guidance of our Honorable Prime Minister, is very focused towards digitalization, and we are incentivizing the young thinkers, the startups. Mr. Pinak is here, he's from a startup, he's doing a lot of things in steel sector. And we also encourage the young persons who have got intention to do some kind of research and in the field of automation and all. So we have got incentives for them and support, financial support for them also, from ministry as well, and SRTMI will be doing separately. So these things are there. I hope there's a bright future for the industry.
That's very encouraging to know that.
Yeah. So taking the opportunity and catching on, SRTMI has 3 verticals. One vertical is dedicated to startups. So please come up through you. I would like to spread the word around. You have got funding available. You have got opportunities available. The biggest thing that you have available, apart from the funds, is the opportunity to test your technology in a steel plant. You see, steel plants normally will not allow anybody else to touch their technology because they have very large process, very dangerous process. But here is an opportunity through SRTMI that you can actually test your technology, whatever you develop, on a live steel plant. So please, I exhort everybody to come into this.
Thank you, Mr. Prakash. Pinak, you wanted to share your perspective on this.
I think, as Joint Secretary Sir just mentioned, I think on his point around capturing data, I think even in the earlier discussion in the panel, we were talking about how important it is to capture the data and process the data, and that is really the foundation of doing any kind of AI. The irony is that as human beings, 70% of the decision that we make is through the data that we capture via our eyes. 70% of the decision that any one of us is making is via the data that we capture and see, right via our eyes. But if you go on a factory floor, any factory floor, steel, metal, aluminum, packaging, food and beverages, all the visual data is completely not getting captured, not getting stored, not getting processed. Yes, you have 100,000 sensors in a steel plant, but the visual data not getting captured, not getting stored, not getting processed. So far it was because of the inability to process it. With the advent of hardware, as you are saying, with the advent of powerful GPUs in the last couple of years, the visual processing is possible now, and which is where I think in the entire effort of like moving forward in the world of digitalization, moving forward in the world of AI, I think next couple of years we'll see a lot of progress in the world of vision AI. And of course, underscore just the point that SAIL Chairman and Joint Secretary just mentioned, the SRTMI and the startups we do see as a startup. I can definitely iterate that as a startup. We do see our doors open to us more in the steel sector as compared to some of the other sectors. So Thank you for all the efforts that you are making to encourage the startups to participate and work with the steel industries.
Thanks a lot, folks. Any questions you have for our panelists? And if you can always use the mic, just specify your name and the organization, and if you can ask the question.
Good afternoon. I'm Nilesh Sinha, heading projects revision of in-house consultancy of SAIL, CET. Basically an automation man. So I have a couple of questions. One is when we were talking about digital readiness, hot strip mill is one area where we have complete digital readiness, where we have level 1. We already have level 2 self-learning and adaptive models, where we use to some extent AI. Then we have this asset monitoring and predictive maintenance also. But what else in this area, like in hot strip mill, like do we have a tool like which can predict the cobble detection, or say predict strip breakage? And when we have all this data ready in hot strip mill, what do you suggest? Should we go for a cloud-based AI tool, or we should build our own LLMs from security point of reason? So this is one question. And second is, of late we have been trying to use these AI tools in our day-to-day work, like offer evaluation, where we got a lot of success. We have also used uploaded drawings, and we have uploaded standards, and where they have given the complete bill of material, and which is almost accurate. We have also used in design calculations, but the problem that we are facing is in the repeatability part. Every time we try it, sometimes we get accurate results, sometimes we get the results are wayward. So we are not sure whether we should use this tool. Sometimes the results are so accurate, exactly we are able to validate with the data sheets that we are already having. But then sometimes it goes haywire. So these two questions, if you can throw some light, where we are not doing the right thing, where we are not getting the repeatability part.
Who wants to take that? Stefano, yeah.
Well, that is quite specific, but I'll try to put forward some considerations. Let us start from the second one. There is not a clear answer. There is not a receipt that is valid for every situation, in the sense that there are companies that are protecting their data as much as they can, and they are very jealous, and they do not allow even the solution providers to use them, to have them, and to use them to develop their solution. There are companies on the other side that are fully open to develop something that is completely integrated in the digital system. Let me put this to the extreme. I know of solutions about standardized equipment in which several units installed in several different plants from several different customers, are all of them communicated with a unique digital brain that is learning from every situation that is giving the best solution for the complete panel of units installed everywhere. So if I put this to an additional level, and also connecting to the first question that you were having, you're basically saying, I have level 1, I have level 2, what can I do more? Look, we have customers that are coming to us and are telling to us, I want to go digital, what do I have to do? And it is a journey. I mean, a solution that could fit to your organization could not fit to our organization. So this is why we talk about joint development and joint innovation. And we also talk about business models in which we are not just selling a package, but we are taking advantage of the added value of that which the package is giving to you. In other terms, performance-based solution. We install a solution and we collect our return when the customer collects his return. And it's always a joint development, because a digital package that is available and suits every single customer or serving the complete industry is simply not available, because every plant is different and every solution is different.
Thank you.
Just, I wanted to maybe add 10 seconds in interest of time, be very crisp. I think in the specific first question that you were asking about hot strip mill, with deviation avoidance, cobble avoidance, and bag coiling avoidance. These are the 3 highest value use cases that you can target in a hot strip mill. And the way to solve it is by optimizing your reheating temperature and your difference between the roller gaps, which are there in the left and the right side in a hot strip mill. I am happy to connect with you outside of the conference and take you through our solutions in detail. But short answer is, overall you can achieve a higher quality by optimizing these parameters in a hot strip mill. As repeat, we have done it several times. Happy to share with you more examples of it offline.
Yeah. So, thank you, folks. And whether to go to cloud or not, it's a nuanced answer. You want to use public cloud, you can get things really fast. You don't have the procurement cycle and everything. But sometimes if the solution is so unique, it's a unique algorithm you want to create with your custom-made robot, maybe you want to keep in-house. Today I'm seeing actually a resurgence back from public cloud to private cloud for some very strategic models and applications. So I think the answer is both based on your use case. Yes, we have another hand up. Yeah.
Hi, Shankoti Mukherjee, CRE Group. So, thank you for the very detailed explanations. My takeaway is that we are really on top of AI, but we are restricting, it seems, it to operational improvement and operational functions. I would be interested to know from everybody in the steel ecosystem, be you be a steel maker or a policy maker, what kind of thinking is there right now in using digital technologies and AI within the strategy functions of an organization? Thank you.
Okay, I'll try to bring a context to this. If you look at an organization, how does strategy flow in an organization, and activities, as you correctly pointed out, activities can be automated. You can put AI on in activities, say, put robotics to control some of the activity. When it gets to strategy, it's a wider thinking. I'll just give you a philosophical answer, in fact, instead of a technical answer, is data. When we talk about data, in itself, data is nothing. You can collect data, you can have data. I can produce a table of numbers in front of you, you will make nothing out of that. When I put headings on the top of that data table, right, this is temperature, this is the temperature at this particular time, this particular point, then data becomes information. Once it becomes information, you start using it. If you have sufficient information, you have data of one time and then of another time, if you are able to compare, then you say, I have got knowledge. Now you have knowledge that different types of information is available to me, I am knowledgeable. And over knowledge, when you put the context of business or whatever your end goal is, purpose, when you put purpose, then it becomes wisdom, then it becomes strategy. So you have to go through the whole chain in order to do strategy. AI can be one of the tools at different stages. AI can capture data, AI can help you in converting that data into information, information into knowledge. And final strategy is the piece where we will get into the whole debate of ethics and everything. So I think that is getting AI into strategy will be a conscious decision on the part of both policymakers as well as industry stalwarts.
And one thing I would love to add is that, and Dr. John, you mentioned that collect all the data and maybe strategically set all the KPIs. Because when we are making strategy, as humans, we often think that we know it all. It is our hunch and gut feeling, devoid of the data. So if we have the right KPIs, and KPIs also needs to constantly change, as a strategy function, then we will be informed. And still, as human, finally, AI cannot take the decision on our behalf. As the term it says, human in the loop. Human should be in charge of strategy till the general intelligence takes over. Yes, next question.
Hi, Anirban Chatterjee from Bureau Veritas Group. Sir, thanks for this insightful session. One question regarding decarbonization part of it now, which is becoming basically a competitive advantage of many steel players globally. How you are showing your performance on decarbonization. We have seen over the years on measuring carbon performance at the product level, LCAs or EPDs, getting mainstream. And of course, on the advent of green steel taxonomies, more and more small and medium scale steel players are also now gearing up how they can, kind of come out with their carbon management performance or product performance as well. So how do you see, the question is, in becoming more competitive and becoming more producing lower carbon or green steel world, AI and is going to play an important role to get the real-time data. Today, what we are getting the data on carbon performance mainly on the past performance on some baseline data or LC or EPD data. But each and every batch by batch or hit by hit number, there are few, startups are also working in this space. But thus, from a policy point of view, if ministry or, the major steel players take a, generalistic platform or develop some kind of a, infrastructure, like we have lot of digital infrastructure, UPI or something for that lot. So any digital public infrastructure can also be developed in this regard to make India ahead of the, other, industries. So if you would like to throw some light. Thank you, sir.
What I understand, you have two parts in your question. One is that we have been measuring the emission on past data. So probably you want to ask whether we can predict the future emission. The emission exactly can be measured from the past data only. The future prediction, of course, the steel producers, they assess their energy efficiency and the process efficiency and set target for the next financial year. That way they are already doing. As far as Government of India is concerned, the Ministry of Power has come up with the CCTS policy, that is Carbon Trading System, in which on the basis of the past performance, they will be setting up the target for all the steel producers, a target, annual target for the carbon emission. If you go above that, then you have to buy the carbon credits, and if you go below that, then you can sell the carbon credit which you achieve. So that policy is coming up. I think it will be implemented in 26. And the platform you are talking about, the platform government should create, we are working on that. The NIST is developing a platform with Joint Plant Committee, JPC, on which everyone can, all the steel producers who wants to project that they are a leader in the green steel, they can feed their data and get the green steel certification from that. That data will be available with the ministry for further analysis. But that is voluntary for now, that is voluntary, but in coming year that will become mandatory also.
Stefano, you want to add something?
Yeah, I also like to comment with a couple of practical examples. Your question somehow was connected to what can be some kind of link between the digital solutions and the green steel. Of course, if a plant goes digital, it will not become green. Green is related to the physical emissions of gases from our plants. But if you consider that with a performance-based digital solution, you're able to squeeze out of your existing facility more efficiently, more output, this will mean that automatically the CO2 footprint, the CO2 per ton of the steel that you are putting out is less. And the contribution can be significant because AI-powered performance-based model acting on the various components and parts of the plants can significantly boost efficiency and so can significantly contribute in reduction of this.
Thanks a lot. I'm conscious of time, and again, thanks audience for your participation. And the feedback I get from all of you, whether the session is going well or not, is how many people are on phones. So when we started, maybe around 30% were on phones. At this point, maybe 10%. And they're trying to figure out how to get their cars to airport and other stuff. So I guess thanks to our esteemed panelists, I learned a lot. I'm not from the steel industry. I do digital transformation for a living. And I learned a lot and really wanted to thank our esteemed panelists for sharing a very nuanced answer. Digital cannot, and thanks Stefano, digital cannot make us green. As long as we are actually digitizing the right bits, it's a great lever to kind of take us to the future. Again, thanks a lot, audience, for your patient hearing. We are between you and the lunch, so thanks again, and thanks a lot, panelists, for your kind of very insightful contribution. Thank you.
Thank you for giving us that enriching experience. So thank you all, and on that note, we conclude India Steel 2025, requesting all the speakers on stage to please step ahead for a group picture. And some announcements for the audience members in the meanwhile. As you leave, if you remember, last evening I had made an announcement regarding the memorabilia. So please fill in your slips, submit them at the registration desk and collect your memorabilia as you leave. Lunch is in Hall 1. Just like yesterday and day before, lunch has been arranged in Hall 1. Kindly partake the same. And thank you all very much once again. This is Amanasi signing off. Have a great time ahead. Thank you.